Hello everyone. This is your first video for Unit 2 Linear Equations unit. So the name of the unit is Linear Equations. Last night your Unit 1 Preliminary Topics exam was due at midnight, 6:15. So now we're moving on to the second unit. Notice there is a lot of pre-class assignments for this first video. So before you watch this video, make sure you've done all of these pre-class assignments. They'll help you to understand the material that I'm going over today. Okay, notice all these assignments will be due 6/27 at midnight, and the test Unit 2 Linear Equations exam is due 6/29 at midnight, 2 weeks from last night. And there'll also be a couple assignments that you have to turn in, actual paper homework, and I'll show you how to do that in the upcoming videos. So this video, I'm just going to explain this first portion up to this post-class assignment, lines, linear equations, and slope. Okay? So, now I'm going to assume as I'm doing this video that you have done all of these pre-class assignments. There are 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 assignments. So plenty to do. Okay. The equation of a line can be written in the form y equals mx plus b. What are x, y, m, and b? So let's write them out. So here I'm going to write x, y, and over here I'm going to do m and b. Now m and b have specific names. M is always what we call the slope, or something else you might hear it referred to as is the rate of change. Like the slope of a mountain, when you're driving and it says 3% grade or 5% grade, what that 5% means is that's the rate of change of the ground, right? It's decreasing at a rate of 5% or whatever it happens to be. B is always your y-intercept. That is the point where the line intercepts the y-axis. Okay? X is your independent variable. Another thing you'll hear me call the independent variable is the input. Independent or input. And Y is the dependent or output. All right, so independent and input, dependent and output, they are synonymous, okay? Most math problems can be created from real-world scenarios, don't come in terms of x and y. In fact, sometimes it's hard to see how any equations can represent a situation in real life. But most everything we do is mathematical in nature. The trick is figuring out how to interpret this. One very important concept comes from understanding the difference between the independent and the dependent variable. So the independent variable is the input, okay? Almost always the x-axis. X-axis. And the dependent variable is the output. Almost always, well, there's only a few cases where it's not. So for the mathematics you guys are going to do, the output is always the dependent variable and the input is always the independent variable. Almost always the y-axis. So a good way to think about it, if you're looking at a chart inside a magazine or a newspaper, whatever's at the bottom is going to be your independent variable, and then whatever's on the y-axis is going to be your dependent. Okay? This is the way it's going to work. X and y-axis. So the dependent variable depends on the independent variable. That's why it's called the independent. Okay. So a good way to think about this is these expressions, this expression is interpreting C in terms of F. If we're going to find C, we have to know F in this case. So therefore, F is our independent variable and C is our dependent variable. Because everything for C is in terms of F, right? What C is in terms of F. So F is the independent. I'll just put in, and C is the dependent. Same with W. W is the dependent. Your wage depends on how many hours you work. So hours is the independent variable. So if I was going to graph this scenario, I would let hours be the x-axis and let wage be the y-axis. All right, and moving down to the next equation. Femur length in inches and h in height. F, femur length is the dependent and h is the independent. Now you might be asking yourself, well, can't I just solve this equation for h? Move the 10.44 over by adding it and then divide by the 0.432. And if you did that, then f would become your independent variable and h would become your dependent variable. So it really depends on how the information is cast to the reader. All right, so in this case, f is dependent. F depends on h. Okay, so we have to know h before we can find f. Okay. So another way to think about it, remember, f of x is another way of saying y. F of x means y, or output. And we write it using this f of x notation, because then it makes it very easy to know what the independent variable is. Well, the independent is x to give us a dependent variable of f. Okay? So let's just look at some of these questions. What can you tell about the slope of the graphed line? What is this thing doing as I go from left to right? Just like I'm reading words on a page. As I go from left to right, this is increasing. The f of x values are getting bigger as I go from left to right. So therefore, the slope of the graphed line is positive. It is increasing. It's like the football or the baseball is gaining, right? It is still going up into the air. Positive. Can you determine the equation of the graphed line using y equals mx plus b? Let's see if we can. So complete the table based on the graph above. So before we answer question B, let's look at question C. So when x is negative 2, what is y? So come over here to where x is negative 2. So here's negative 2 on the x-axis, and y is negative 1, negative 2, negative 3. Y is negative 4. When x is negative 1, y is negative 3. When x is 0, y is negative 2. When x is 1, which is right here. So right here, x is 1. Y is negative 1. And then when x is 2, y is 0. This point right here is what is known as our y-intercept, because this is where it intercepts the y-axis. So this value, whatever it is in terms of y, is the b term. So the y value where the line crosses is negative 2. So I know b is going to be negative 2. b equals negative 2. Y equals, it's going to stay a variable just like x. Y and x aren't, we're not going to evaluate them for anything. Y and x are just going to be variables because they range, they go over this entire range. So x can be any number from negative infinity to infinity, and y can be any number from negative infinity to infinity. So now let's look at m. So I know b, so I know I can find this term, so I still need to find my m before I can write the equation of the line. Remember, m, I said, is slope. M is the slope. The definition of slope, which some of your videos up here talk about it, right here, calculate slope. So you've actually had to do it a little bit. The formula for slope, M equals the change in Y over the change in X. Another way you might hear this stated is rise over run. Because notice, change in Y, this has to do with a vertical change, right? Because our Y-axis is vertical. So this has to do with either rise, or as we'll see when it's a negative slope, will fall. And change in X is a horizontal measurement. So that's always run. So that's why it's rise over run. Change in Y over change in X. So right here, let's just look at our change in Y. Here our change in Y is -4 minus -3. That becomes +3, so that's -1. Here our change in Y, -3 minus -2 equals -1. And so on. As we do this, we will find that our change in Y's are going to be the same. They're going to be -1. What do you notice about the change in Y values as X increases by 1? So as X gets bigger and bigger, the Y values get bigger and bigger, right? Because it goes from -4 to -3 to -2 to -1, and so on. You know, but you might ask, well, if this is negative, that says a negative slope. But up here you told me the slope was positive, so how can that be? Well, that's because, remember, our slope is the form of change in Y over change in X. So I'm going to go over here to M, and I'll just take any of my change in Y points. So let's do -4 minus -3. Now our X values have to correspond. So if I'm using Y as -4, I have to use the X value that corresponds to it. So it becomes -2 minus the X value that corresponds to Y being -3 is -1. So it's be minus a -1. So this equals -4 plus 3 is -1. -2 plus 1 is -1. -1 over -1 is +1. So this does go back and show me that my slope is positive. So now, since I know M, I know B, I can plug these directly in to this formula. So notice all I really need is 2 points to create this line. Even if I didn't have this y-intercept, there is a way to find what this value is using even just these 2 points. Okay, so I'm going to plug these values into this function. Can we determine the equation of the line? Let me go down here and write B. Y equals M is +1. So I'm not going to write anything. We'll just call it X, 1X. And my Y-intercept is -2, so I'm going to plug in -2 for B. So the equation of this line is Y equals X minus 2. Another very good tutorial on this stuff is here in Khan Academy. Graph a line in slope-intercept form. Notice here, look, they have an M is 1/3 and a B is -2. That y-intercept happens to be the exact same thing. So this video will help you understand what I'm covering here. So another extra resource for understanding the material. Let's look at the next one. Example 2. Now notice as this line goes from left to right, it's falling. The y values are getting smaller. So what this would lead me to believe is that the slope is negative. So let's go in here. What I'm going to do is I'm only going to use 2 points. So I'm only going to worry about -2. When X is -2, what's Y? Well, Y is 1, 2, 3, 4. Y, 1, 2, 3, 4, 5. Y is 5 when X is -2. So I'm going to call this 5. And when X is -1, it's 1, 2, 3. Y is 3. And for fun, we'll say when X is 0, Y is +1. So there's my Y-intercept. So I know B equals -1 equals 1. Let's worry about m. So m, our slope is change in y, so 5 minus 3, over change in x. So you have to use the same 2 points, negative 2 minus negative 1. This equals 5 minus 3 is positive 2. 2 minus a negative 1, this becomes positive. Negative 2 plus 1 is negative 1. So that means my slope itself is negative 2. So now I can go in and draw the line. Y equals negative 2x, right? Because this is my m value. And b, positive 1, is my y-intercept. And I can verify this formula by taking any one of these x values. When I plug it into this formula, I better get back these y values, right? They have to correspond to the graph. So let's just try it. So let's plug it in. When x is 2, I'm going to plug in 2 for x. So that's negative 2 times 2, so that's negative 4 plus 1, so it's negative 3. So my formula says when x is 2, y should be negative 3. Let's verify it from the graph. When x is 2, y is negative 3. So it does work out. Okay? Now let's look at this line. This is a different type of slope. As I read it from left to right, it looks like it's flat. It's not increasing or decreasing. This line seems to parallel with whenever you go outside in the evening and you're looking at a beautiful sunset. The horizon is this straight line, right? The horizon has this same shape. That's why we call this line horizontal, because it has the root word horizon. So horizon is flat, just like a horizontal line. What can you tell about the slope of the graph line? It's flat, or it's horizontal, right? That's what I can tell about the slope. It's neither increasing nor decreasing. So let's see what happens here. So what is my b value? When x is 0, where does it cross? Where does the y-intercept get, or where does the y-axis get intercepted? Right here at 3. But what is it when x is negative 1? Well, notice y is 3. And when x is negative 2, y is 3. So I know b is definitely 3. Let's find m. M equals change in y over change in x. So 3 minus 3 over negative 2 minus 1 minus negative 1, which gives us 0 over negative 1, which is 0. The slope of a horizontal line is always 0. So notice if I plug in 0 for m, 0 times x goes away. Right? So there is no mx term in this line. So the equation of this line is simply y equals 3. And if you look at the graph, it makes sense. No matter what x value you tell me, you can even say when x is 1,000,000, what's y? Well, when x is 1,000,000, y is still 3. So y is 3. It does not depend on x. There is no independent variable right here. All right, so a horizontal line is of the form y equals a constant. Y equals whatever the y-intercept is. Look at the next example. Now, this line is the opposite of horizontal. It goes straight up and down, which is the word vertical. Now you can also say that this line, as I go from left to right, it's neither increasing or decreasing, because depending on how I look at it, I could say, well, it looks like it's decreasing, but then somebody can come up and say, well, it also looks like it's increasing. So let's see what happens here. First, let's look at our b. So what is our b? When x is 0, what's y? So here's x is 0. Where does this cross the y-axis? Notice it doesn't. It does not exist in this case. The only way for the y-intercept to exist is if it actually was on the y-axis itself. And then it would be all real numbers, right? There would be infinite y-intercepts. So when x is negative 2, what's y? Well, y is everything. When x is negative 2, y is 1, 2, 3, 4, 5, 6, right? It's all these different, it's infinite. Y is infinite. So if I'm going to take any of these y values, I could say 10, 5, 0, negative 5, 10. So I could figure my numerator of my slope. So I could say m is 10 minus 5, right? So I'm going to take this point up here and this point. And that's going to be the 2 points that I use. All right, so let's say 10 and 5. So 10 and 5, so I need to use the x's that correspond. So negative 2 minus negative 2. This gives me 5 over 2 plus 2 is 0. That means this is undefined. The slope is undefined and there's no y-intercept. So this line is simply the equation x equals negative 2. No matter what y is, x equals negative 2. So vertical and horizontal lines are kind of very specific examples of lines. If it's horizontal, it's always the form y equals something. If it's vertical, it's always the form x equals something. The other lines where the slope is either positive or negative become much more interesting to look at. All right, like our first two examples. Those are the ones we're going to see more and more throughout the semester. Okay. So what types of lines can be written as a linear equation? So let's summarize this by this box. So first we have a positive slope, which was our example 1. This is example 1. Slope's positive, the behavior from left to right increases. And the equation of our line is y equals mx plus b, and our slope, our m, has to be greater than 0. The y-intercept doesn't have to be greater than 0, but the slope does. Let's consider the negative slope. The behavior as it goes from left to right is decreasing. And the equation of the line is y equals mx plus b, where m is less than 0. This is just like example 2. Then we have two very specific types of slopes. We have a slope of 0, and then we have a slope that's undefined. When the slope's 0, the behavior from left to right is horizontal. When you have a slope that's undefined, the behavior from left to right is vertical. And the equation of this line is always y equals b, and this one's always y equals whatever the x-intercept is. We'll call it x-intercept, because there's not a specific name for the x-intercept. And this one was example 3, and this one was example 4. So that is the 4 types of lines you will see: positive slope, negative slope, 0 slope, or an undefined slope. Okay? Let's think about this. Draw 2 lines with slope 2. How many different lines are possible? Let's take one that goes through the origin, and then do a slope of 2. So we're going to rise 2, run 1. Rise 2, run 1. And connect the dots. So how many other lines can I draw with the slope of 2? Yeah, I could let one have an intercept of positive 1, one have an intercept of negative 1, one have an intercept of positive 5, negative 5. I could draw another line right on top of this. So how many different lines are possible? There is an infinite amount. Because no matter how many lines you drew, I could always come up with another one. No matter what. What do you notice about your lines? They have equal slope, right? In order for all groups to generate the same line with the slope of 2, what other information do you need to specify? The y-intercept. So we need both of those things in order to specify a specific line. Not just the slope, not just the y-intercept. Because I could draw a bunch of lines here with the slope of 2, right? A bunch of lines. So I need both of those pieces of information. I need the slope and the y-intercept. Both pieces. Okay. So now let's go in here and talk about what makes something linear or not. In order for a line to be linear, or for a set of points to be linear, excuse me, is that the rate of change is constant. So all the slopes are the same no matter what 2 points I pick, which makes sense because it's in a straight line. So let's go in here and look. First, let's look at our differences here. Notice our step size in each place is 1. So our x is changing by 1. Now let's look at what our y is changing by. Our y is changing by 2, by 2, by 2, by 2. So this is a constant change. For every 2 y changes, x changes 1. This would be linear. My equation is y equals, my m is going to be rise over run, so 2 over 1. If you want to see it again, I'll write it down here. So let's pick 2 points. Y equals -5 minus -3 over -2 minus -1. Which equals -5 plus 3, which is 2. -2 plus 1 is, oh, this is -2, excuse me. -5 plus 3 is -2. -2 plus 1 is -1, so that is +2. So y equals 2x, but what is our y-intercept? Notice it is put in here. When x is 0, y is -1, so our y-intercept is -1. I could use this point in my slope. I could use any combination of these 5 points. I could use this point and this point. I could use this point and this point. I just have to make sure that this correspondence happens, that -5 and -2 are the same point, and -3 and -1 are in the same point. Let's keep going. Let's look at the next example. So here, this thing keeps stepping up by 1 each time, right? Our x is changing by 1. Here our y is changing by 2, but then here it changes by 3, so it's not a constant change. This is 2 to 1, but this is 3 to 1, so this is not linear. I can't create an equation. Remember, your rate of change must be constant, or the same, no matter what 2 points. Or slope, right? Rate of change or slope must be constant. Or not change. M is a constant. Right? This value of 2, this is a constant. It is a specific number. Let's look, I'll skip that second one. Let's look at a little more difficult one. So let's do this one. So the difference between -8 and -2 is 6. And I'm kind of ignoring signs at first just to see if it's showing linear tendencies. So this difference is 2, this difference is 4, this difference is 2. Now our step size here aren't equal as they have been in the previous examples, but they don't have to be. It's the ratio of change in y over change in x that has to be equal. So here our difference is 3, here our difference is only 1, here our difference is 2, and here our difference is 1. So here, notice it's 3 to 6. So when y changes by 3, x changes by 6. So that means one of my slopes is going to be 3 over 6. The other slope is going to be 1 over 2. The other slope is going to be 2 over 4. And then 1 over 2. Notice that even though these fractions aren't the same values, they are all equal. They're all equal to 1/2. 1 over 2. Rise of 1 over run of 2. So this is most definitely linear. Erase a little one. So y equals 1/2 x. And my y-intercept is 0. When x is 0, y is 0. So b is 0, so that is the equation of my line. And I'll leave these other examples up for you guys to try. Now let's actually get in and construct some lines. Okay. We have a linear equation whose rate of change is 2. So they tell you right off the bat that it is a linear equation. So the slope of 2 is constant. We also know that 1, -2 lies on the line. First, complete the ordered pair solutions, 2 comma something, 4 comma something, and -2 comma something. So first let's draw in this line at 1 comma, negative 2. So right here is the point 1, comma, negative 2. 1, negative 2. So we know the rate of change is 2. So m equals 2, which is the same as 2 over 1. So that's my rise over run. So I'm going to rise 2 and run 1. I'm going to take this point, rise 2, run 1. So there's my next point. 1, 2, run 1. And it's asking for when x is 4 and x is 2. So I'm going to go out again. Rise 2, run 1. Jeez. Rise 2, run 1. So here, how do I go backwards? So a way to go backwards or to the left of this point is to do the opposite of rise. It's to fall. So it's to fall 2, and instead of running forward, we're going to run backwards. So we're going to fall 2 and run backwards, run 1. Once again, we're going to fall 2 and run backwards 1. So there's our points. So when x is 2, what is y? Well, when x is 2, y is 0. 1, 2, y is 0. So that's a point 2, comma 0. Then we have the point 4, comma something. So 1, 2, 3, 4. 1, 2, 3, 4. So it goes through the point 4, 4. And when x is negative 2, notice I'm not here, so I need to do it one more time. 1, 2, and over 1. Then I could draw a line. And I'm drawing this with a computer, so it's kind of hard to be exactly straight. The pixels are just a little off. Let me try it one more time. A little better. Okay. So when x is negative 2, what's y? Well, here's negative 2. 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8 right there. So when x is negative 2, y is negative 8. Now it says draw the graph of the linear equation and label the 3 points. So we haven't created the equation. I've just simply graphed it and I'll label the 3 points. So this is 2, comma 0. This is negative 2, comma negative 8. And this one is 4, comma 4. Haven't even created the line, but I can. So remember, the line is always of the form y equals mx plus b. I just found my m is right here. It's 2. So y equals 2x. And where does this cross the y-axis? It crosses the y-axis right here, which is 1, 2, 3, 4, which is negative 4. So the equation of this line is right there. Y equals 2x minus 4. This is a very important ability to have, okay? You have to be able to take 2 points, find the slope, and be able to construct the line from 2 data points. We'll be doing that a lot throughout this summer. So you have to make sure to understand how I came up with this stuff. Now the rate of change, the slope, was given to us, so we didn't have to do too much math, and that's how we created these other points. All right, we have 2 ordered pairs that lie on the same line. So now it gives us 2 points. That's all we know. 2 data points. That's all you need to create the line, is 2 data points. So first is calculate the rate of change or slope, right? Rate of change and slope mean the same thing. So for part A, I'm going to find m, which is change in y over change in x. So I could do 2 minus 3 or 3 minus 2. It doesn't matter what order. So I'm going to go ahead and do 2 minus 3. Now what's important is if I use 2 here, I have to use the x value that corresponds. So I'm going to do negative 3 minus 0. Equals 2 minus 3 is negative 1. Negative 3 minus 0 is negative 3. So our slope here is 1/3. That is the value of m. So let's plot the points and draw the line. So 0, comma 3. This is our y-intercept, right? That's where x is 0, so that's where it's crossing the y-axis. So this value is my b term. Remember, your y-intercept is always going to be of the form 0, comma b, because it's where x is 0. When x is 0, you are crossing the y-axis. So let's plot those 2 points, 0, 3. So 0, 1, 2, 3, right there. And negative 3, 2. So 1, 2, 3, 1, 2, right there. So there's our line. Notice it's pretty flat, right? It's not really, it doesn't have a quick incline like this line. Right? This line had a big slope. It had a slope of 2. This line only has a slope of 1/3, so it's not gaining nearly as fast. So that's why the line looks a little bit flatter. And then it says write the linear equation. So B is plotting the points and drawing the line. So this is the point 0, 3. This is the point negative 3, 2. Part C is y equals, here's my slope, 1/3 x, and B is right here. B is 3, so plus 3. So any value I would pick for x, maybe I come out here and pick x is 8 or 10. I plug it into this formula, whatever I get back for y will plot on this line, right? Now this is drawn by hand, so it's not exactly perfect. So I might not go through the point, but that's what this line represents. This is an infinite collection of ordered pairs that satisfies this equation. That's what a line is. All right. Let's go one more. This one's a little more difficult because we aren't given the y-intercept, right? We'll have to use some mathematics to come up with the intercept, the y-intercept. So part A says first find the slope. So rise over run, right? Change in y over change in x. So I'm going to do 2 minus negative 4 over negative 6 minus 3. This equals 2 minus negative 4. That becomes 2 plus 4, so that's 6. Over negative 6 minus 3 is negative 9. So this equals negative 6/9, which reduces to 2/3. Notice here I moved the negative to the numerator. It's bad etiquette to write your negative in the denominator of a fraction. So always move it to the top, and our answer is negative 2/3. So that is definitely our slope. Okay, so let's go ahead and plot the points and draw the line. So let's find negative 6, 2. 1, 2, 3, 4, 5. There's negative 6, 1, 2. So there's 1 point on the line. And our other point is 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. There's the point 3, negative 4. And notice that our line is decreasing, which is supported by our slope we found here. Try and connect these as best I can. Whoa. One more time. So there's the line. Here's our slope. So as of right now, this is what I have. I have y equals negative 2/3 x plus b. But I don't know what b is. I can look at this graph and maybe estimate it at negative 2, but look how squiggly my line is, so you can't verify that. You know, I could try and go, fall 2 and run 3 and see if it's actually on the graph. So let's try that. Let's go here. Let's fall 2, 1, 2, and run 3. 1, 2, 3. And then fall 2 and run 1, 2, 3. So it actually does fall exactly on the graph in this case. It is negative 2. But let's do that mathematically. I'm going to show you an algebraic way to come up with this value for b. So I don't know b. I know this has to be the slope. And I have 2 points that are part of this equation. So I can pick either one of these points and plug them in. Plug negative 4 in for y. Plug 3 in for x. And then I'll just have a formula with one variable with b. Then I'll solve for b and come back and plug it in. So what I'm going to do now is I'm going to pick this point, 3 comma negative 4. It doesn't matter which one you pick. I'm just going to pick this one. I'm going to let y be negative 4. So this is to find b, if I couldn't from the graph. So I'm going to let y be negative 4, so it becomes negative 4 equals negative 2/3 times, what's the x value? Well, the x value is 3 plus b. So b still are unknown. So now let's just solve this equation. So it's nice here, negative 2/3 times 3, the 3's just cancel. So I'm left with negative 4 equals negative 2 plus b. And to solve for b, I need to add 2 to both sides. And that implies that negative 2 equals b, which is exactly verified by our graph right here. So I'm going to plug in negative 2 for b. So the equation of my line is y equals negative 2/3 x minus 2. And there's my equation of my line. Okay? So just to verify, I could take this point, negative 6 comma 2. When I plug in negative 6 for x, I better get back positive 2, because that's the y value. So I'm going to check using this point, negative 6 comma 2. So I'm going to plug in negative 6 for x. So y equals, well, I'm going to go ahead and plug 2 in too. Do it right now. So I want to get 2 on the right hand side. So 2 equals negative 2/3 times negative 6 minus 2. So there's my 2 points that I plugged in. I put parentheses around them to show that I plugged in. So now let's just keep going. So now I have 2 equals, 3 goes into negative 6, negative 2 times. Negative 2 times negative 2 is positive 4 minus 2. And then I get 2 equals 2. So it does check out. All right. So this assignment, this lines, linear equations, and slope is right here. It's a post-class assignment. What I'm going to do inside this post-class assignment is I'm going to attach this video as part of the assignment. So it'll just make it easier to get to this video. You'll have to just open the window up and you'll be able to start the assignment. All right, this is due 6/27 at midnight. If you notice here, you want to work on this stuff pretty quick because our next group of assignments are due barely the Thursday night of that week. So there's not, the next group of assignments are due very quick. The next exam is actually only a week later. Right? There's not a 2-week span because Unit 3 is really short. So you really want to get into this Unit 2 stuff and get on it, Get as far as you can. The next video I'll make tomorrow in post is this graph to solve systems of linear equations. So we'll talk about that, and then we'll do some applications of solving systems of equations, where the applications are mixture problems. If I mix 10% solution with a 30% solution, how much do I need of each to yield 25% solution? So that's where we're headed next, and I'll make these videos tomorrow. All right, so if you have questions, email me. We can set up a hangout on Google+, or maybe I could just answer them through email. But go ahead and get started on this stuff. Everybody have a wonderful day.